Hi guys, welcome back to my channel. So before we start, I would like to thank all those who subscribe and those who are supporting my channel. Alright, so for those who are not yet subscribed, please don't forget to hit the subscribe button and the notification bell for more videos. Alright, so for today, we're going to talk about special parallelograms, trapezoids, and kites. So in the last video, you were able to have we are able to have the introduction about quadrilaterals and the properties of parallelograms. In this case, by applying those properties of parallelograms, we're going to talk about the different special parallelograms, including trapezoids and kites. But we will start first with special parallelograms. So the question that we're going to have now, or that we're going to answer later on, is that what make these parallelograms special? Alright, so there is something unique with them, that's why they are special. So let's start with the first type of parallelogram or special parallelogram. We call it rectangle. Okay, guys, rectangle is a parallelogram as well with the right angle. So as simple as that. It is a special type of parallelogram because of the property, which is it has right angles. So as you can see, it has 4 right angles. When we see right angles, so the measurements are 90 degrees. Alright, so if we're going to still add 90 plus 90 plus 90 plus 90, it is still the degree measure of a quadrilateral, which is 360 degrees. Okay, so let's talk about the other properties. Of course, other than the 6 properties of parallelograms that we discussed last time, so 6 properties rather. Okay, so namely we have 2 pairs of opposite sides are parallel. Okay, so 2 pairs of opposite sides are congruent. 2 pairs of opposite angles are congruent as well. Alright, so then diagonals bisect each other. Then diagonal actually form two congruent triangles as well. So those are the 6 properties that we had last time. Alright, so other than those 6 properties, what's with a rectangle? So it has 4 right angles. Okay, just like what you are seeing in the illustration, it has 4 right angles. Then the third one, it has, or its diagonals are congruent. So as you can see, if we're going to draw the diagonals of the rectangle, let's say these are perfect diagonals. So we can say now that segment AC is congruent to segment BD or segment DB. That's it. So there are 2 additional properties other than the 6 properties of parallelogram. So we have, it has 4 right angles, and then the other one, its diagonals are congruent. Alright, so let's proceed to the other one, rhombus. Of course, rhombus is also a special type of parallelogram. Why? A rhombus is a parallelogram that has a pair of consecutive congruent sides. Alright, so consecutive congruent sides. So in simple manner, as you can see, all the sides are congruent. All the sides are congruent. So they must have the same measurements for us to say that the specific parallelogram is a rhombus. So other than the 6 properties that we have, we also have the other 3 properties. Of course, it has 4 congruent sides. Just like what you are seeing in the illustration, it has 4 congruent sides. Then the third one, its diagonals are perpendicular. So if you are going to draw the diagonals, okay, when we say perpendicular, at that intersection, you are able to form right angles. That's what we mean. So its diagonals, unlike a rectangle and the typical parallelogram that we know, alright, so we can just say that diagonals bisect each other. But in this case, we can also say that the diagonals are perpendicular, or they form 90-degree angle. And the fourth one, each diagonal bisects the angles of the rhombus. What do you mean by that? So let's say this is the illustration. We can say that this angle is congruent to this angle. This angle is congruent to this angle. And then this angle is congruent to this angle. And this angle is congruent to this angle. Alright, so simple as that. There are 3 additional properties that we have, okay, for us to say that rhombus is a special type of parallelogram. Okay, so in rectangle there are 2. In rhombus there are 3. Let's proceed to the next. Square. So a square is not just simply a parallelogram. So a square is a parallelogram, a rectangle, and a rhombus that has 4 right angles and 4 congruent sides. So in the illustration, as you can see, it has 4 right angles and also the sides are congruent. So that's why we call it also a rectangle and rhombus, because all the properties of additional properties of rectangles and additional properties of rhombuses are in square. That's why it is not just simply a parallelogram, it is also a rectangle and rhombus. So those are the things that you have to take note for us to say that a specific parallelogram is a square. Okay, so as you can see in the properties, all the properties of parallelograms, all the properties of rectangle. Okay, what are the other two properties of rectangle? Diagonals are congruent, and the other one is um, diagonals are congruent, and then all the angles are right angles. And then third one, all properties of rhombus. Okay, so it has 4 congruent sides, diagonals are perpendicular, and also diagonal bisects the angles. All right, so simple as that for us to say that a parallelogram is a square. Okay, let's proceed. So to better understand if what are we talking about, okay, about special parallelograms, let's use the Venn diagram. So in this specific Venn diagram, the yellow is of course the universal set, and inside the universal set we are all talking about the parallelograms. Okay, so in the first circle, okay, we have the rhombuses, and then in the second circle we have the rectangles. So as you can see, okay, the intersection of rhombuses and rectangles are squares. Squares, why? Because we can say that a square is a rhombus and a square is also a rectangle. Okay, because all the properties of parallelograms, rectangles, and rhombuses are in square. Okay, so as simple as that. Okay, so if you're going to encounter a true or false question regarding if or a yes or no question regarding if a square is a rectangle and if a square is a rhombus, of course, okay, so that's the answer is yes. Okay, a square is either a rectangle or rhombus. Let's proceed to this one. Given rectangle RSTU, so segment US is equal to x minus 2 over 2 plus 2x plus 3 over 6. So segment US is actually one of the diagonals, just like what you are seeing, the one that I'm marking right now. It is a diagonal. And segment RT measures x over 3 plus 1. So this is segment RT. So according to the property of a rectangle, diagonals are congruent. So therefore, for us to be able to answer this one, actually we are looking for segment RT. So that's the other diagonal. So we have to state first the congruence using the property of having congruent diagonals in a rectangle. Okay, so we can now say that segment US is congruent to segment RT. Then afterwards, we can now substitute the values for us to solve for the value of x. Okay. Of course, we have to solve for the value of x for us to be able to solve for the unknown. Alright, so substitute the value. So as you can see, class, there are denominators, or the givens are fractions. Don't worry, okay? So if that's the case, I'm going to teach you the easiest way to eliminate the denominators for us to easily solve. Alright? So segment US measures x minus 2 over 2 plus 2x plus 3 over 6 equals segment RT, which measures x over 3 plus 1. So the next thing that we're going to do now is to eliminate the denominators. So for us to eliminate the denominators, we have to identify the least common denominator, okay, so which is divisible to the denominators 2, 6, and 3. So in this case, the LCD that we have is 6. Okay, so we can now eliminate by dividing to the denominator and multiplying to the numerator. 6 divided by 2 is 3. Then 3 times x minus 2. Then 6 divided by 6 is 1 times 2x plus 3. So which is also 2x plus 3. Equals 6 divided by 3 is 2 times x. Then, so since the denominator of this is 1, we can just simply multiply. 6 times 1 is 6. Then the next thing is we have to apply the division property of equality for us to simplify 3 times x minus 2. So we will just distribute 3. 3 times x is 3x. Then 3 times negative 2 is negative 6 plus 2x plus 3 equals 2x plus 6. What did we just apply? We apply the distributive property of multiplication. And then in this case, we will be applying the addition property of equality so that we will be able to combine the similar terms. Okay? So, what are the similar terms here? 3x, 2x, and 2x in the other side of the equation. So, bring down 3x, bring down 2x, and then the opposite of 2x is negative 2x, equals, we will now combine the constants, negative 6, 3, and 6. So, bring down 6, and then opposite of negative 6 is positive 6. Opposite of positive 3 is negative 3. Now we can already simplify it. So 3x, then 2x minus 2x is simply 0. Therefore, this is equal to 6 plus 6 is 12 minus 3 is 9. So solve for the value of x by dividing both sides by 3 using the property division property of equality. Divide both sides by 3, we're able to have now the value of x, which is 3. So since we already have the value of x class, we can now solve for segment RT. So segment RT, according to the given, measures x over 3 plus 1, wherein the value of x is 3. Substitute the value of x, which is 3 over 3 plus 1. So 3 over 3 is just simply 1 plus 1. So therefore, the measurement of segment RT is 2. This will serve as your final answer. As simple as that, guys. So first is we will be identifying the property that we can use. Alright, and then solve for the unknown variable, and then that's the time that you can actually solve for the unknown value. So if you have a question regarding this, or if you have a comment or suggestion regarding this on how we can actually simplify the process of solving this one, please hit the write your suggestions on the comment section. Alright, there's no problem with that. So if there's something wrong or error, okay, so please make sure to send me a personal message so that I can actually correct that. Thank you so much. Let's proceed to example number 2. Quadrilateral or parallelogram ABCD is a rhombus. Okay, so by just maybe in this specific example, they follow the different properties of a rhombus. That's why they call it a rhombus. Then the measurement of angle CAD is 35 degrees. Find the following. So the measurement of angle BAC, the measurement of angle BCD, and the measurement of angle ABC. So for you to easily answer this, guys, please make sure to write the specific measurement on the part of the illustration for you to easily solve it. So in this case, angle CAD measures 35 degrees. So by applying the property diagonals bisect the angle, so we can also say that this measures also 35 degrees. Alright, so we will start from there. Now let's have letter A, the measurement of angle BAC. So the measurement of angle BAC is this already, and the measurement of angle BAC is congruent to the measurement or equal to the measurement of angle CAD. So therefore, we can say that the measurement of angle BAC is also 35 degrees. That's already one of the answers. Then letter B, the measurement of angle BCD. So where's angle BCD? BCD. So this is angle BCD. We have to apply the property of parallelogram that opposite angles are congruent. Okay? So we can already say that the measurement of angle BCD is the sum of the measurement of angle BAC plus the measurement of angle CAD. Then as you can see, opposite to angle BCD are the measurements 35 degrees and 35 degrees. Just simply add them. 35 degrees plus 35 degrees is equal to 70 degrees. So that's already the answer. So it means that this is 70 degrees. Okay? Now let's have letter C. In letter C, we have to get the measurement of angle ABC. So this is angle ABC. So we can apply the property of a parallelogram that consecutive angles are supplementary. So therefore, if we're going to add angle B and angle C, we will be getting 180 degrees. So to get the other measurement, just like angle ABC, just simply subtract 180 degrees minus the measurement of angle BCD. So therefore 180 degrees minus 70 degrees. So the answer here is 110 degrees. That's the measurement of angle ABC. So just write it, 110 degrees. So we can also apply the property opposite angles are congruent. So therefore we can say that this also measures 110 degrees. That's it. Then you can also check if your answers are correct or if the angles are correct by adding them, and the sum must be equal to 360 degrees. Okay, so for us to say that it is a quadrilateral. So 110 degrees plus 70 degrees plus 110 degrees plus 35 plus 35. What's the answer? Very good. It is 360 degrees. Okay, 360 degrees. Okay, very good, guys. Alright, so for my students, if you have a question regarding this, just simply send me a personal message. You know how to contact me. Thank you. Now, let's talk about trapezoids. So what are trapezoids? So a trapezoid is also a type of course, a quadrilateral, with exactly one pair of parallel sides. So unlike a parallelogram, it has two pairs of parallel sides. But in this case, it only has one pair of parallel sides, just like what you are seeing. So these parallel sides are what we call the bases. This one we can write it as base sub 1. This one is base sub 2. And then the other two sides are what we call the legs. This is leg sub 1. This is leg sub 2. Alright, so what's the difference of it from parallelogram? It has only one pair of parallel sides. Okay, next. So we're not going to talk about any more trapezium. When we say trapezium, the sides are not congruent. Okay, so we will just be talking about isosceles trapezoid. So what is an isosceles trapezoid, class? An isosceles trapezoid is a trapezoid with congruent legs. Okay, so as simple as that. It has congruent legs. What are the properties? The base angles of an isosceles trapezoid are congruent. So it means that these angles are congruent and these angles are also congruent. Okay, so we can say that these angles are congruent and these angles are also congruent. How about the leg angles? The leg angles are supplementary. Remember those things. Okay, and then the diagonals of an isosceles trapezoid are of course congruent. Just take note of the properties. Okay, so because we're going to use those properties whenever we solve for the unknown angles and sides. Okay, let's proceed. Example 3. In an isosceles trapezoid ABCD, just like what you are seeing in the illustration, the measurement of angle A is equal to 3x plus 40, and the measurement of angle D is equal to x plus 60. Find the measurement of angle B. Just like what I'm seeing a while back, just mark the measurements. According to the given, the measurement of angle A is 3x plus 40, and this one measures x plus 60. What we have to solve is the measurement of angle B. So before we can solve for that, we have to solve for x by stating the property that base angles are congruent. Okay, so we can say that the measurement of angle A is equal to the measurement of angle D. So first we have to solve for x. So equate the measurement of angle A is 3x plus 40 equals the measurement of angle D, which is x plus 60. Applying addition property of equality, we will have to combine the similar terms. So 3x and the opposite of x is negative x equals, bring down 60. The opposite of 40 is negative 40. 3x minus x is 2x equals 60 minus 40 is 20. Then, okay, to simplify or to solve for the value of x, divide both sides by 2. Therefore, x is equal to 10. So that's just the value of x, guys. Okay, so all we need to do is to solve for the measurement of angle B. So, but before we solve for the measurement of angle B, we have to apply the property that leg angles are supplementary. So if that's the case, we have to solve first for angle A. So the measurement of angle A, according to the given, is 3x plus 40, wherein the value of x is 10. Substitute the value, 3 times 10 plus 40. 3 times 10 is 30 plus 40, so the measurement of angle A is what? 70 degrees. Then the next in class, since we already have the measurement of angle B, or rather angle A, we can now solve for the measurement of angle A. Measurement of angle A is 180 degrees minus the measurement, rather this is angle B, sorry. Angle B is equal to 180 degrees minus the measurement of angle A. Substitute the value, 180 degrees minus 70 degrees. Therefore, the measurement of angle B is 110 degrees. So that's already your final answer. Okay, so what we did first is we actually apply the property, then after that solve for the value of x, solve for the value of A, or measurement of angle A, for us to solve for the measurement of angle B. Alright, so let's have median of a trapezoid. Properties. So the median of a trapezoid is parallel to its bases. Okay, so in the illustration, the middle one, or the line or the segment in the middle, is what we call the median. So the median of trapezoid is of course parallel to the bases. So here's the formula. The median of a trapezoid is half the sum of the lengths of the bases. So for you to easily understand this one, just simply add the bases and then divide the sum by 2. That's it already. Okay, let's have the following examples. So the lengths of the bases of a trapezoid are 17 centimeters and 11 centimeters. How long is its median? So first of all, we have to state the formula. Median is equal to base of 1 plus base of 2 over 2. Actually, class, we can interchange with the place of base of 1 and base of 2. There's no problem with that. Then substitute the values. Base of 1 is 17 centimeters plus 11 centimeters, which is base of 2 over 2. Then 17 plus 11 is 28 divided by 2. Therefore, the median is 14 centimeters. So this is now your median. As simple as that, class. Alright? So if the median is missing, just simply substitute the bases to the formula. That's it. So how about if the given is this? Example 5. ABCD is a trapezoid with segment EF as median. If EF is 2.3 and AB is equal to 4, find DC. So EF is your median. Okay? So the missing is not the median, rather it's the base, which is segment DC. So write again the formula. Median is equal to base of 1 plus base of 2 all over 2. Then substitute of course first the representation of the values. So the median is segment EF equals AB is 4, but let's write it first, plus segment DC all over 2. Then substitute the values. Okay, segment EF is 2.3. Then segment AB is 4 plus segment DC over 2. For us to simplify this, we just simply apply cross multiplication. 2.3 times 2 is 4.6 equals 4 plus segment DC. That's it. We can already apply the addition property of equality to combine the constants. So 4.6 and the opposite of 4 is negative 4 equals segment DC. So segment DC now is equal to 4.6 minus 4 is 0.6. So that's already your final answer. Segment DC, or one of the bases, measures 0.6 or 6/10. Okay? Next, let's talk about kites. What are kites? This is the last type of quadrilateral that we're going to talk about. So what makes it different from parallelogram and trapezoid? Okay? So a kite is a quadrilateral with two distinct pairs of consecutive sides that are congruent. So what do we mean by that? So in the illustrations, we can say that segment BC is congruent to segment BA and segment CD is congruent to segment AD. So that's it. That makes it different from parallelogram and trapezoid. No? So and then, let's have the following properties. So first property, diagonals are perpendicular. So it means when the diagonals intersect, okay, so they form 90-degree angles at the intersection. Alright? So the number 2, exactly one pair of opposite angles are congruent. So these are the only angles that are congruent, guys. Okay? There are no other opposite angles that are congruent. Then diagonal bisect each of the non-congruent angles, and the other diagonal. So we can also say that this angle is congruent to this angle, and this angle is congruent to this angle. That's it. Now, let's talk about the area of a kite. Don't be confused of this, guys, because it is quite similar to the formula of the median of a trapezoid. The area of a kite is half the product of the diagonals, okay? So here's the formula. A is equal to d sub 1 times d sub 2. Just simply multiply the measurements of the diagonals, d sub 1 and d sub 2 over 2. You can actually interchange the d sub 1 and d sub 2. There's no problem with that. So don't be confused on the formula because it is quite similar to the formula of median. But in the median, you are going to add the bases. In this case, you're going to multiply the diagonals. Okay? So d sub 1 times d sub 2 over 2. Example 6. Given kite MNOP, if NP is 2.5 centimeters, okay, so this is NP, and MO is 4.5 centimeters, find the area of MNOP. Alright, so for the area, it is A equals D sub 1 times D sub 2 all over 2. Substitute the values. D sub 1 measures 2.5 centimeters times segment MO, which is 4.5 centimeters all over 2. Okay, so the next thing is we're going to multiply 2.5 and 4.5. So 2.5 times 4.5 is 11.25. 11.25. Then divide it by 2. So the answer is, the area of the kite is 5.625. So this is already your final answer. Don't forget to write the unit. Since it is area, you have to write square centimeters. Okay? For area, the answer must have a unit of square unit, of course. Okay? So that's already the area, 5.625 square centimeters. Alright, let's have the last example. Example 7. Given kite QRST with area 27 square centimeters, find TR if QS is 4.5 centimeters. Alright, so take note of this, guys. We're not looking for the area because the area is given. We're looking for one of the diagonals, which is segment TR. Okay, so write first the formula. A is equal to D sub 1 times D sub 2 all over 2. The area is given as 27 square centimeters. Substitute, wherein D sub 1 is 4.5 times the unknown, which is segment TR, over 2. Cross multiply. 27 times 2 is 54 equals 4.5 segment TR. Then divide both sides by 4.5. Okay, so what is the answer? Is it 12? So 54 divided by 4.5, of course it is 12. So therefore the area, segment TR is equal to 12 centimeters. Do not put square centimeters because it's not the area, it's just one of the diagonals. So one of the diagonals, which is segment TR, measures 12 centimeters. Okay, that's it. Now we are able to finish the different types of quadrilaterals. So starting from parallelograms, we also had trapezoids, and then the last one is kite. So don't forget that when we are dealing with quadrilaterals, we're talking about the four-sided polygons. Alright? Now, don't forget the different properties of each type of quadrilateral, so that whenever you solve for the unknown angles and unknown sides, you're able to actually apply the right property. Because if you're not able to apply the right property, of course you're not going to get the right answer. Okay? Now for my students, please answer this one, and then we will be checking it next meeting. Okay? So I would like to thank you so much for being with me today, okay, at this moment. Alright, so please don't forget to hit the subscribe button and the notification bell if you learned something today. Okay, and then to all my supporters, thank you so much, and I really appreciate you all. So thank you so much. God bless, and have a nice day to everyone.